of your calcification, right? Same thing happens here, but here calcification is treated as an internal resistor. That's the thing. Then what is your AH capacity? Because that's what it boils down to. When I can tell my battery is dead, because in humans it is easier to say that your oxygen capacity gone down, your heart rate is so and so forth, so you can call one can call system as a dead. But here even at 60 amperes, and we do lot of cyclings. Nowadays I don't do it, but that's cycling and all that thing is just to give you an example like what really cycle numbers are. So how we define the cycles, what are the norms to define the cycles, they are already there. You can go to UNEC website of European Union, FP7 and all that. So you go ahead and you essentially will realize how they are correlating the cycles to the user experience. So SIS1, SIS2, which anyway I was mentioning, that is part of it. I will just touch upon the battery safety issues and I will stop here because this presentation is bulky. I know first 15 minutes, 20 minutes I took a part on that, explaining the bus architectures and all that. So typical cell electrolyte leakage, vapors, overpressure capturing. So you must have heard pyrofuse, right? Pyrofuse does the job of protection in case of thermal runaway. So if you want to learn more about thermal runaway, go for 38.3. UNEC, UN 38.3, this is a standard. T1 to T7 are the tests. UNEC R100.2.3, now 3 is already out. It talks about annexure A to annexure 9, or A, B, C, D and 9. So all this talks about how to characterize the battery and how to test the battery, how to qualify the batteries. In fact, same goes for the vehicles also. R10 is for your EMI EMC, R13 is for your braking test, 85 is for your tilt test and so on and so. 107 is for tilt test. So go through it, see what are the tests required, how they are correlated. Even 154, 155 is for cyber security because charging infrastructure is now fully automated. No one goes, yes, in India it is not yet, but no one goes and says that please charge the vehicle. It is like you connect the charge, your wallet gets automatically debited as soon as you connect the vehicle. So if you want to go into that mode, go and see plug and charge, you see open charge protocol, OCPP we call it. So just have a look at it, you will realize people have already advanced to the next phase where it is like what we do in UPI, same can be done in the charger. So go park the vehicle, connect the charger and done. VIN identification automated, charging wallet is automated, charging operator is automated. So all completely automated now. It is not someone like I choose my charger, you choose, no, nothing. Interoperability is also automated. So with this I will stop here. All design considerations, high level design considerations and everything are already mentioned in this PPT. Have a look at it at your leisure and do drop me emails at any point. Based upon my availability, I will try to answer. Thank you. Any questions or all good? Or this one.
Hello. So whenever we say we want to charge the batteries and discharge the batteries, so actually in EV batteries how that structure should be and how architecture is designed?
As I said, this slide has all the things. Essentially, this is the typical architecture we talk about. So we call it as a CMU, cell management unit, which is at 48 volts. And we connect them in series to arrive at 600 volts per pack. And such packs are branched out to make it parallel system. So you will see fuses, you will see contactors there. And that complete pack, now I call it, like, let's say this 3 pack, and everyone is at 50 kilowatt hour. So then 50 into 3, 150 kilowatt hour is your capacity of the battery. So Now if you see the kind of management systems working there, so these are all connected through CAN. So if you want to learn more about CAN 2.0, you must have gone through that, or J1939 SE. That is the best standard describe how CAN protocol, SPNPG and all CAN protocols work there. So generally we connect batteries on CAN. Now PO is also coming into picture, or over Ethernet, and that protocols are also there. So go to Google Matter or anything, you will hear like that. So cell balancing, voltage, temperature monitoring, HVI, because electrical continuity is must here, you can't get rid of that. So we call it high voltage interlock systems. Then module current monitoring, because as I said to you, between the branches also current monitoring is extremely important during charge and during discharge. We don't want SOCs to be different more than 2%, or to be precise 1%. Even at minus 20 degrees centigrade, there is morning cold start operation to let's say 45 degrees when you are going on this peak of the night. Then diagnostic and CAN, because if CAN is broken or CAN is wired communication is broken, then we literally halt the vehicle on the ground. We don't allow the vehicle to move forward or even backward, not even by inch in both directions. The reason is naturally for the safety. So components, as I said, battery cells, battery management system, connectors, contactors, and these are all as per your safety analysis. I will briefly touch upon it. Let's see how it works. Yeah. Functional like that. So we effectively do this kind of analysis to come out with this kind of architecture. So when we say my battery is R100.2 compliant or .3 compliant, and we essentially do atom definition in the functional safety requirement. So what is my trip time? What is my contactor opening time? What is my contactor closing time? If my contactor doesn't give me the feedback, what should be my fallback plan? And so on and so forth. So you try to Medina analysis or someone if you have used it by chance, then you can do this kind of activity, and that will define the functional safety goals, and where that goals begin, work on. So this is that product level requirement which anyone I was talking to you. This is your XY structure. So here that modular design specifications is here. So whatever you are asking, right, what my capacity should be, what should be my architecture look like, why I should connect the batteries in parallel, how much battery I should connect in series, what is the energy that I am handling at any point in time, whether it's a charge, discharge, thermal runaway, how I can stop propagation of heat, so on and so forth. That is defined at that, I will say, product requirements and system level specifications. So whoever is doing system engineering job has to go through 360-degree view from, we call it as cradle to grave, plus behavioral analysis to come up with architectures. So sorry, I can't give you in the prescriptive format answer, but that's how the process is. And these are the standards I mentioned it. You can do that. So if you see that every test that I am mentioning, starting from stability to start circuit, this is all covered on 2464 or ECR100 or your AIS 048 now it's again changed at the time as we speak, because recent ruptures at Ola and Uber not Uber. Okay. So effectively push our government to change some standards or align our standards to R100. Previously we were not aligned to R100. R100 is like mother of invention kind of thing. Where from there you even FMESS 204, 304 all are derived from R100. So R100 is a master copy. From there you see all architectures are defined or their safety goals are defined. And same holds true for body and chassis system, same holds true for your other kind of thing.
Sir, the video you shown that video, and in that video, suppose that electric vehicle is stopped by any reason, then another vehicle will charge it.
Yes.
How it will happen? That means it is wireless or wired?
So I understand. See, Hence I was showing in that vehicle there is one port, we call it our ISO port or CHAdeMO port, which is your conductive coupler port. So if you go to charging systems, okay, I don't have right now time otherwise. So there are charging ports available. So if you go to Tata Nexon or any other vehicle running on the road, you will have charging ports. So that ports are already being incorporated into our vehicles. So we incorporate AC charging for that vehicle, but yes, it is low wattage. And it is practically a port-to-port connection and communication happens.
No, my question is related to whether it is wired or wireless.
Wired.
Wired. Okay. Thank you, sir.
So braking is still mechanical or
Braking is category B, mechanical plus visual. But yes, mechanical is always the preferred option because of the and it is fail-safe brake. So if you go to locomotive brake, if your air system is not charged, locomotive doesn't move by your means. It is locked. If no more questions, then thank you again quietly listening. Best of luck for your next sessions.
Thank you, sir. Thanks for giving insights into the various parts of EV. This will definitely extend our knowledge in the field of EV. So now we will take break of 15 minutes. After that, next session will begin.